Project 2.2.3 The Morse Code Decoder. The Morse Code Decoder is comprised of 5 main subcircuits: the voltage regulator, LCD interface, parameter interface, Morse audiovisual representation, and the fiber optic communication system. The Arduino Nano operates at 5 volts, which is significantly lower than the 9-volt source voltage used in the circuit. Although the Nano includes an onboard voltage regulator, it can only supply approximately 150 to 200 milliamps, which is insufficient to reliably power all the components in the circuit. To address this limitation, an external L7805 CV 5-volt 1-amp linear voltage regulator is used. The L7805 has 3 pins: voltage in, VIN, ground, and voltage out, VOUT. VIN is connected to the 9-volt supply voltage and is referenced to ground. A 10 microfarad capacitor is placed between VIN and ground to filter input noise and stabilize the voltage. The regulated 5-volt output is taken from VOUT with a 1 microfarad capacitor connected between VOUT and ground to improve output stability and reduce noise. The excess voltage is dissipated as heat by the regulator. The LCD uses 16 pins for control and data transfer. VSS and VDD are connected to ground and 5 volts respectively. The VO pin controls display contrast and is connected to ground through a 100 kilo ohm potentiometer, allowing manual contrast adjustments. The RS, or register select pin, determines the type of data being sent. When high, the LCD interprets incoming data as characters, and when low, data is treated as control instructions, for example, clearing the screen. The R/W read-write pin is tied to ground, configuring the LCD in write-only mode. The enable pin acts as a latch, allowing the LCD to read data presented on the data pins. Pins D0 to D7 are used for data transmission. The LCD operates in 4-bit asynchronous parallel GPI mode, meaning that no clock signal is used and data is transferred in parallel all at once through general-purpose input/output pins. In 4-bit mode, the higher 4 bits are sent first, followed by the lower 4 bits, forming a complete 8-bit ASCII character. The A and K pins power the LCD backlight LED and are connected to VCC and ground respectively. If text exceeds 16 characters, the print LCD function shifts the characters left to prevent characters from being cut off. Fiber optic communication is achieved by transmitting Morse code using an LED that sends light pulses through braided PMMA optical fibers to a receiving light-dependent resistor. The PMMA fibers consist of a plastic core surrounded by a cladding with a lower refractive index. When light strikes the boundary between the core and the cladding at or above the critical angle, total internal reflection occurs, allowing the signal to travel through the fiber with minimal loss. The received light pulses are then interpreted by the Arduino Nano and translated into English text. The parameter interface consists of 3 slide switches that control communication type, buzzer activation, and LED activation. For each switch, one terminal is connected to VCC and the other to ground, producing a clear digital high or low signal. The center terminal is connected to the Nano's input pin. The Nano continuously monitors these inputs through 3 conditional ternary statements to adjust the setting. Morse code input is performed using a PBNO button configured with a pull-down resistor. When pressed, the button sends a high signal to the Nano, which then processes and transmits the signal either electrically or optically via the LED. A buzzer and LED provide real-time audio-visual feedback during Morse code transmission and reception. These components activate when the Morse signals are sent or received, depending on the user's selected settings in the parameter interface. Thank you for watching my video on the Morse code decoder.